Hi students, welcome to Narayana virtual classes. This is Venkat. Today the assignment topic is laws of motion, class 9th. This is assignment 8. Here mainly 5 questions are there. Let us go to discuss question number 1. See the question here. When can we say a system is isolated? So, isolated system means when you say the body is isolated system means, so that net external force act on a body is 0. So, means that you should take any object, you have to apply some forces on the object, this is F1 and same force act on the another direction, that is F2, and this is F3 in the vertical direction and this is F4. Means that what is meant by isolated body? When you say the body is isolated means when your external forces acting on the body means total net forces, the total net forces acting on a body, total net forces acting on a body is 0. That body is known as isolated body or isolated system. So, this is the answer for question number 1. See the question number 2 here. The question is, what are impulsive forces? What are impulsive forces? So, impulsive forces means the force exerted by an object is over limited a time, over a limited a time. Means you have to impulsive force, you have to represent letter J. J is equal to, impulsive force J is equal to, you have to define force into time. You have to define force into time. Means impulsive forces means the force exerted over a limited interval of time is known as impulsive forces. So, see that here formula impulse is equal to F into time or change of momentum mv minus mu. Then what is units of impulsive force? Means you know very well kg meter per second. So, that is the importance of impulsive forces. Next, coming to the third question. So, see the question here, why it is safe to jump on sand rather than cement floor. See here, when you jump on a sand, here see here when you jump on a sand, here the feet is move or penetrate into the sand, it exerts some force on a sand is less amount of force exerted on a sand. The result, the sand also exert same force on a feet. So, that is why what happened here, when you jump on a sand, it exerts less force on a sand. The feet exerted less force on a sand. So, the resultant, the less amount of force, equal force exerted on a feet, okay, according to Newton's laws. For every action there exists equal and opposite reaction. So, same like that only, when a feet is exerted less force on a sand, the resultant also, the sand also exerted same equal forces on a feet. So, coming to the second one here, cement floor. When you jump on a cement floor, the feet is penetrate on a rigid floor, it exerts, the feet exerts more force on a cement road. So, that is why the result also, the cement road also exerts the same equal force on a feet. So, the result is we have to hurting from the cement road. That is why here in the compared to the sand surface, the cement surface produce more force on a feet. Okay. So, that is the answer for question number 3 here. So, that is why we have to jump to sand is a safe rather than cement floor. Next, coming to the fourth question here. See the question here, why does a pole vault jumper land on a thick mats of a foam? See here, especially pole vault jumper land on a thick mats, okay, thick mats foam. Okay, this thick mats foam act like a cushion, like a cushioning form. So, it is act like a cushioning when that jumpers is land on a this type of mats, it is safest. Why? Because it is reduce the more injuries, it reduce the more force on a sand like a mats. That is why this thick mats foam act like a cushioning. So, in case there is no any thick mats is not available when the pole vault jumpers is contact with the ground, the body is contact with the ground, they are hurting from the ground. Okay, that is why mostly we have to using that mats. Why? Because these mats act like a cushioning finally to reduce the injuries, okay, from the ground surfaces. So, that is importance of this mat, like thick mats. Okay. So, that is the answer for question number 4 here. Next, coming to the fifth question, derive m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is the law of conservation of momentum derivation. See the derivation here. Yes. For example, you should take two objects in a straight line. This is the first object, mass m1, and second object, mass m2. First object, before collision, the first object velocity is u1 and second object velocity is u2. If u1 is greater than u2, then what happened before collision? What are the movement of the two bodies? First body momentum p1 is equal to the product of, what is the momentum here? The product of mass and velocity. That is why you have to write m1 u1. And coming to second body, before collision, second body momentum p2 is equal to, second body momentum p2 is equal to m2 u2, m2 u2. So, when that u1 is greater than u2, the body is colliding, the first body colliding the second body after t time. After collision, these two bodies maintain the velocity. The first body m1 having the velocity is v1 and second body velocity is v2. Second body velocity is v2. After collision, the two bodies velocities, the first body velocity is v1, second body velocity is v2. After collision, the momentums are, the first body momentum is m1 v1 and second body momentum is m2 v2. So, these are the momentums, these are the before collision momentum is m1 u1 and second body momentum is m2 v2. After collision, the first body momentum is m1 v1 and second body momentum is m2 v2. Now, let us we have to find what is the rate of change of momentum. First of all, what is the change in momentum? Change in momentum means p2 minus p1 is equal to m2 u2 minus m1 u1. So, before collision, change in momentum is m2 u2 minus m1 u1, and also here after collision, change in momentum is m2 v2 minus m1 v1. So, this is the after collision change in momentum. Next, you have to find rate of change of momentum. Rate of means you have to compare with time, means rate of change of momentum. Rate of change of momentum delta p by t is equal to m2 u2 minus m1 u1 by t. Okay. Here also m2 v2 minus m1 v1 by t. So, this is the rate of change of momentum before collision and after collision. Next, according to that Newton laws, here the first body acts some force on a second body is F21. F21 means the first body acts some force on a second body is F21. This force is equal to, and same way second body acts some force on a first body, that means F12. F12 means the second body acts some force on a first body is F12. These two forces are equal. According to Newton laws, F21 is equal to minus F12. Here minus indicates opposite direction. That is why here this is the force, this is the F12, this is the F21 and F12. These two forces are equal. That is why here you should write like that, m2 u2 minus m1 u1 is equal to m2 v2 minus m1 v1 by t. Here tt get cancelled, here minus is there, here minus is there. So, that is why here finally we get the formula here. Here m1 u1 is there, m1 u1, this m1 u1 send that side. Okay, here minus indicates me this one is coming plus. Okay, finally we are getting here m1 u1 plus, okay, here remaining is there m2 u2 is there. Okay, m2 u2 is equal to m1 v1 plus m2 v2, m2 v2, this is the derivation. So, this is the derivation for law of conservation of momentum. Okay. So, this is the law of conservation of momentum. What is the formula? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So, this is the derivation for law of conservation of momentum. Okay, this is the assignment today. Next time we have to discuss with another assignment. Until, keep smiling. Thank you.